This is the Tabletop Illusion. It's by far my favorite illusion, and I hate it. I hate almost everything about it. The reason I love it so much is because I think it's one of the most powerful visual illusions. And because there's a lot of detail behind how it works, and it's actually kind of easy to understand. The reason I hate it so much is because although I understand exactly how it works, I cannot make myself overcome the illusion. Many illusions, when you see how they work, you can see past it. But not this one, no matter what. The illusion is that the top area of the tables are exactly the same shape. Same width, length, height, same dimensions, everything. I'll prove it to you on my computer. So I have a polygon and it perfectly covers the surface area of this tabletop. So I'm going to copy that, and if I rotate it exactly 286.3 degrees, then I can place it. I'm going to try to be super precise here. There you go. Now, it's not absolutely perfect. There's a little bit of black and a little bit of white showing through, but that is true on both of them. These are exactly the same shape. Now that you know that, can you actually make your brain see these two as identical? I bet you can't. To figure out what's going on, we have to understand how our brains process information. I'm sure you've seen a Neker Cube before. Here's one of those. Now, what's fun about the Neker Cube is you can make it flip spontaneously by imagining either the top square or the bottom square facing you being the front-facing surface of it. Now, this works because a Neker Cube isn't a real 3D object, but we can pretend that it is. You can imagine and see it that way. Here's an attempt to make a real Neker Cube, and as you can see, it's paradoxical. This is an impossible shape. Here's a genuine 3D empty cube, and you can't make the front-facing side flip to the back anymore. When you look at something that's facing you head-on, your brain automatically understands that its true width isn't how wide it appears in your field of view. That might sound pretty mundane, but it's actually pretty remarkable. It doesn't seem special because it's something that our brains are incredibly good at. So we take it for granted. But we take in enormous numbers of clues from the environment in order to make sense of objects that are skewed one way or the other, mentally rotating them without even trying. What makes the tabletop illusion so bizarre is that it takes advantage of the way our brains rotate real objects in the real world. If these tables were real, then their tops would not be identical at all. If we rotated the left table to match the orientation of the one on the right, it would appear much longer and skinnier in real life, if it was a real table. The bottom lip of the table and the table legs, those work as environmental clues, and they override our brain's ability to see the tops by themselves for what they are, as the exact same shape. Now let me be clear here. I'm saying if these were real tables, then they would not be identical. Their tops wouldn't be the same dimension, but that's not the point of the illusion. The point of the illusion is, even though that you now know for a fact that the tabletops are the exact same shape, you can't make your brain see them that way. Another less obvious illusionary part of the tabletop illusion, although it's not the main point, is the far edge of the skinny table. If you really look at it, it appears to be wider than the closer edge of the table. They are in fact exactly the same width, but our brains can't make sense of that either. Why is that? Well, because a real table that's the same width, the far edge looks skinnier. It's not as wide in your field of view because it's going away from you. Your brain knows if two objects, one close and one far, appear the same width, it's because the distant object, in reality, is larger. Our brains are extremely good at understanding reality and being able to tell the difference between a real and a fake object, but it's really not obvious for all the reasons why that is. Take Unreal Engine 5, for example. Why does it look so realistic? Well, one of the biggest reasons has to do with the way it uses light. See, in the real world, when light strikes objects, that light is bouncing off of other objects. My black office actually has a green tint to it. Now, you can't really tell, but there's a giant window right here, and there's grass and trees right out in front of it. So there's a little bit of green to the wall all the time. We call this bounce lighting, and Unreal Engine has really good bounce lighting, and that helps make the object seem so much more real. Even though you're not noticing the bounce lighting, it's just there, and your brain sees it, and your brain goes, oh yeah, that's what reality looks like. I can't tell you why, but that is what reality looks like. If you take a look at this little Lego thing, you can see there's a little bit of blue appearing on the red pieces and a little bit of red appearing on the blue pieces from bounce lighting. Here's another example that messes with the brain. This was taken outdoors, so the sunlight is reflecting off of my phone, and as you can see, the reflections and the shadow are so perfect that it actually looks weird. Now, the reason it looks weird is because light from the sun comes to us parallel. Normally, this never happens. Indoor lights are close sources of light, so the light is always scattered, so you don't get perfect reflections like this with normal light. So your brain knows that this image is really unique and really different, but you don't know why. Here's a different kind of illusion. There are no red pixels in this image at all, and I'll prove that to you by using the eyedropper color matching tool on my computer. Here's our color wheel, so I will grab the eyedropper tool, and I think up here that looks very, very red, so we'll go with right there. And as you can see, it's not just gray, it's actually slightly cyan. Let's grab a region over here where there's pretty strong light as well. I mean, when you look at that zoomed in part, that absolutely looks red. But when I click, there you go. Once again, gray, but tinted a little bit cyan. Cyan more so than anything. The parts that are supposed to be white, like the inside of the strawberry, those are actually kind of like a turquoise teal. And we'll do one more just for the fun of it. I think we'll grab from right here. That definitely looks red, at least on the left. But then I can't even really tell that it changed at all. Now, if you think that's messed up, watch this. See how that just became red? Now, what happens if we do this? I don't know about you, but I very strongly see a gradient where it goes red and then it transitions to gray. What the heck is going on here? Well, our brains do color correction all the time. The light you see out in nature, it isn't purely white, it's tainted blue by the sky. So our brains have evolved to subtract a tiny bit of blue light from all the things we see. That helps us see images for the way they truly are. Now, I said always, but actually our brains only do that in the presence of blue light. For example, in the grocery store, where the lighting is white, the apples don't look more red there than they do outside. Now, in this original image of the strawberries, they are red, but all of the red parts of this image have become either gray or slightly cyan due to an overlying blue filter. Our brains color correct by subtracting a tiny bit of blue like they normally do. Now, if you start with gray pixels and you add a little bit of blue, but then you subtract a little bit of blue, well, that just equals gray, but the strawberries don't look gray, they look red. What's going on is your brain is being tricked. Your brain can't reconcile the fact that there's a little bit of blue to start off with, even though it's actually super obvious because the entire thing has that blue outline to it. So instead, what your brain does is it goes, oh, strawberries? Okay, so we have gray minus a little bit of blue, and that's where the red-looking tint comes from. I think the takeaways here are that illusions illuminate to us that our brains are both more amazing than we realize, and we are so easily fooled. Maybe seeing is believing, but that's not the same as what is real or what is true. We have to question things. The scientific revolution literally started by accepting the idea that Earth moves around the sun, even though it doesn't look like it does. There are important lessons to be found here. For example, we now understand that eyewitness testimony is basically one of the worst or most unreliable, at least, forms of evidence in court. Imagine if we were so proud of ourselves that we never actually learned that lesson and all the injustice that that would cause. Keep in mind that we are far from uncovering all of our shortcomings. Stay smart, people. It's too risky not to. Thank you for watching.